So hi everyone to another video. So today we will be going through all the definitions and some problems based on it. First of all, let's revise what is Cartesian product. So Cartesian product is nothing but two sets A and B, which is being denoted by A cross B. It is a set of ordered pairs. The first one we will be going with a small a and the next will be a small b. So this small a will be belonging to our capital A and our b will be belonging to the capital B. So the key point here is to remember that a comma b is not equal to b comma a unless and otherwise a is equal to b. And if A has m elements and n number of elements in B, then A cross B has m cross n elements. So moving on to visualizing. First, you can see x-axis and y-axis. This represents ordered pair from R cross R. So like this, if this is 1 and this is 2, you'll be representing this point as 1, 2. That's the order pair. Next diagram, a set diagram. Two sets connected by lines showing all possible pairings between their elements. Let's say this set as A and this set as B. This set has 1, 2, 3, and here we got A and B. So the mapping goes like this. So such pairings of lines between the elements between set diagram. And in third, you can see a table format where you can represent elements through rows and columns. So in table, you'll be having some like this. So where you will be going with numbers, any numbers, thus representing the elements of the first set and the second set. Going with the examples then. See the first example. We got A equal to 1, 2 and B equal to 3, 4. Then what will be A cross B? That is Cartesian product of A cross B. So in A, there are 2 elements and in B, there are 2 elements. So in A cross B, we have to get 4 elements. That is nothing but 2 cross 2. So how we are gonna write those 4 elements? It is A cross B and not B cross A. Please note it down first. So first, the first number of A, that is 1. Then the next number, 3. Then the same, the first number and the second number of B. Next goes the second number of A and first number of B, second number of A and second number of B. So always go in the same order. Always write the first element of the A and then go with the B. Likewise, if they would have asked you what is B cross C, then what will be the answer? It will be 3, 1, 3, 2, 4, 1, and 4, 2. So this will be the answer. See, A cross B is not equal to B cross A. In second example, in A we have got 3 elements and in B we got 2 elements. So it is 3 into 2, which is 6 elements which we have to get for A cross B. So those 6 elements are being written over here. In third example, A has P comma Q and B has P comma Q. So A cross B will be P comma P, P comma Q, Q comma P and Q comma Q. As always, what we did in the first two sums. Next. So long we saw about two sets of Cartesian product. What if we have triplets? That is 3 sets of Cartesian products A, B and C. So you will be having M cross N cross P elements. Example, in A it is 1, comma 2, B has 3, comma 4, and C has 5, comma 6. Then what will be the A, comma B, comma C? So as I said, first go with the first number, which is 1, then with the second number 3, then this C term 5. Then finish the C, 1 and 3 as always, and finish the 6. Now just change the 3 into 4. Next, we finished all the elements with 1. Now we have to go with 2. Like 2, 3, 5, 2, 3, 6, 2, 4, 5, and 2, 4, 6. Thus, we will be having 8 elements. That is nothing but A has 2 elements, B has 2 elements, and C has 2 elements. So it is 2 cross 2 cross 2, which multiplies will be equal to 8. Thus, it will become 8 elements. See here in this diagram, a real world application. It's a 3D coordinate in a space which represents X, Y, and Z axis. You can even imagine your wall. You'll be having a line like this, and this in your corner of your room. See that corner. That will be a real world application too. Next, going on with the examples. In first question, we will be having A as 1, 2, 3 as our element, and in B, they would have given X, and that X is the prime number less than 10. Hope you all know what is a prime number. And they are asking elements less than 10. So what are those? It will be 1, 2, 3, 5, 7. So these will be our elements. Yeah, of course, 1 won't be coming as prime number. Sorry for that. So the prime numbers less than 10 are 2, 3, 5, and 7. And we are going to find what is A cross B. So for A cross B, as similar as what we did. The A has elements 1, 2, 3, and B has elements 2, 3, 5, 7. So in A, 3 elements, and in 10, 4 elements. In B, there are 4 elements, so totally we will be getting 12 elements as our answer. Here see, we would have also found out what is B cross A. The same 12 elements, but in different order. Here also, please note, A cross B is not equal to B cross A. In next question, they are giving you what is B cross A. And we have to find what is A and B. So the first represents the P. That is, all the first element belongs to the P set. So that is -2 is one of the element, 0 is another element, and 3 is another element. So see, the B is -2, 0, and 3. And for A, all the elements which is in the second. So that is 3 and 4. That's it. So 3 and 4 are the elements in A. So in either way, you can know how to answer the question. Here's the next question. A is equal to 5, comma 6. B is equal to 4, 5, 6. And C equal to 5, 6, and 7. So if we would have asked A cross B cross C, then we would have gotten 2 into 3 into 3. 18 elements in total. But what we have asked here, A cross B intersection C, A cross B equal to A cross B intersection A cross C. We have to prove this property. So for that, we have to find our LHS, that is our left-hand side. In that, first, always please check the brackets first. Then do the remaining. So in here, the bracket is B intersection C. So here B intersection C means what are the elements similar in B and C? 5 and 6 are the elements similar in B and C. So we have written B intersection C equal to 5, comma 6. Now we have to do A cross B intersection C. That is, A is having 5, comma 6 and B is having 5, comma 6. That is B intersection C, I mean. So what is this 2 cross? That is here 2 and here 2. That is, we will be getting 4 elements in total. That is what been written over here. Similar way, we have to find the RHS. That is our right hand side. So there are 2 brackets over here. One bracket A cross B and another bracket A cross C. Then we have to intersect. So for A cross B, that is 5, comma 6 and 4, comma 5, comma 6. So 2 into 3, you will be getting 6 elements in total over here. And for A cross C, it is also 2 and 3. So here also 6 elements in total. So intersection, you'll be knowing all the elements which is similar. See 5, comma 5, 5, comma 6, 6, comma 6 is over here. 6, comma 5 is also there. I think that's it. So only 4 elements are repeating. Those are the intersection. So over here, we are written the intersection point. You can see our RHS and our LHS is equal. Thus, the property is being verified. In the same property, we are going for the next sum. Here A, B, and C and D are being given. And we have to check A intersection C cross B intersection D equal to A cross B intersection C cross D. So here A and B are having 3 elements, C is having 2 elements, and D is also having 3 elements. For our LHS, we have to find A intersection C, which will be the common element between A and C, which will be 3 over here. Then B intersection D. What is common between B and D? It is 3 and 5. So for these two, we have to cross. We have to find our Cartesian product. So here 1 element and here 2 elements. So of course, we will be getting 2 elements in total over here. Then for our RHS, we have to find what is A cross B at first, which will be here 3 and 3, we will be getting 9 elements in total. Then C cross D. So in C, there are 2 elements and D, there are 3 elements. We will be getting 6 elements in total. Then we have to intersect. So we have to find what all the elements which is common, and we are gonna write it. So here also you can see our RHS and LHS is equal. Thus the equation is true. Moving on with the next property, which is called distribution property. Here A, they are giving you X belongs to W and X is less than 2. W belongs to the whole number. Then in B, they are given X belongs to N, 1 less than X less than equal to 4. N belongs to natural number. So what is A now? It will be less than 2. Whole number is 0, 1, 2, 3, etc. And natural number is 1, 2, 3, etc. So less than 2 alone, we have to know. So A is equal to 0, comma 1 alone. Then for B, it is less than equal to 4. So, of course, for your natural number, they didn't give you 1 less than equal to. They just gave you 1 less than. So, it will be from 2, 3, and 4 alone. Then for C, they have already given it is 3, comma 5. Now for the first part, A cross B union C equal to A cross B union A cross C. So same thing, LHS we have to prove B union C. Our B is 2, 3, 4 and our C is 3, 5. So for union, we have to plus. It is like a plus. So we have to write all the elements in B and all the elements in C without repeating. So 2, 3 and 3 again repeats. You don't want to write. Then 4, then 5. So these will be your B union C. Then you will be going with your A cross B union C. So in A, there is 2 elements. In B union C, there is 4 elements. In total, you will be having 8 elements. Then going on with your RHS, you will be finding what is A cross B first, then A cross C next. For A cross B, you will be having 6 elements in total. And in A cross C, you will be having 4 elements in total. Then you have to union. That is, you have to write all the elements together. So starting with 0, 2, 0, 3, 0, 4. Sorry. Yeah, 0, 4, 1, 2, 1, 3, and 1, 4. And then 0, 3 we already wrote, so there's no need to write again. 0, 5 will be coming, 1, 3 we already wrote, and 1, 5 we have to write. Now please check what is our RHS and our LHS. They will be equal, so LHS is equal to RHS, that's our property is getting proved. In second, the same, but with intersection. A cross B intersection C equal to A cross B intersection A cross C. Let me erase all the inks over here. So B intersection C. In B and C, only 3 is the element which is common. Now we have to A cross B intersections. That is in A 0, 1 is over there, and here only 3 is there. Of course, we will be getting 2 elements in total. So for RHS, A cross B, A cross C, we already know from over here itself. We have to just do intersecting. That is, what are the elements common? So 0, 3 and 1, 3 is common over here. Thus, we are writing those things around. So here also our LHS is equal to RHS. It has been proved. For a third one, A union B cross C equal to A cross B union B cross C. We have to prove this next. In LHS, A union B first we have to do. So it is combination of A and B together. And it will be 0, 1, 2, 3, and 4. Then we have to Cartesian product with C. So in C, it is 3 and 5, only 2 elements. And here A union B, we'll have 5 elements. In total, we will be getting 10 elements. So in RHS, A cross C and B cross C has to be found out. That is, A cross B will be having 4 elements, and for B cross C, we will be having 6 elements, and we have to union. That is, we have to write all the elements without repeating. Here, please see, note the LHS is equal to your RHS. That's the property getting proved. Now prime numbers and special sets in this. So let A be the natural numbers less than 8. So that is 1, 2, 3, 4, 5, 6, 7. And B is a prime number less than 8. So 2, 3, 5, 7. And for C, it is set of even prime number. The only even prime number is 2, of course. So now we have to prove A intersection B cross C equal to A cross C intersection B cross C. So in A intersection B, you can see what all the elements common in A and B. So those will be 2, 3, 5, and 7, which is equal to RP. So A intersection B cross C is equal to B cross your C. The C is just your 2. So we have to Cartesian product and we will be getting 4 elements in total. For our RHS, we have to find A cross C and B cross C first. So in A cross C, you will be getting, here we are having 7 elements and here only 1. So of course, we will be getting 7 elements in total. For B cross C, we will be getting 4 elements in total. And we have to intersect. That is only the common elements. So 2, comma 2 is over here, 3, comma 2 is there. 5, comma 2 is there and 7, comma 2 is there. Only these 4 elements are being common. Now, LHS and RHS are equal. That's the property getting satisfied. Next, we have to prove A cross B minus C equal to A cross B minus A cross C. So, B minus C. In B, we are having elements 2, 3, 5, 7. In C, we are having 2. So what is the meaning of minus? We have to neglect the element 2 in B. From B, we have to minus C. So, C, B minus C is the element without the element 2. It is just 3, 5, and 7. Now, as usual, A cross B. So, in A, there are 7 elements, and in B, there are 3 elements. So, we will be getting around 21 elements, right? So, all the 21 elements are being given over here. Then, moving on with that RHS, A cross B and A cross C has to be found out, which we already know. Then we have to remove all the elements. So when you remove, of course, you will be getting all these 12 elements. You can please do it as a homework. And you can find that LHS is equal to RHS. Please try it for yourself. Let's practice some small questions. The first question, if ordered pair x plus 1, comma y minus 2 is equal to 3, comma 1, what are the values of x and y? They are asking you. So what we have to do? So ordered pair x plus 1, y minus 2, and they are saying it is equal to 3, comma 1. So this is equal to 3 and this is equal to 1. We have to make it into an equation. From our first equation, we can find x, which is 3 minus 1, which is equal to 2. And from our second equation, we can find what is y, which is 1 plus 2 equal to 3. Thus, we are getting our answer, 2, comma 3. So, x is 2 and y is 3. The option A will become our correct answer. In next question, they have given our sub P, then our Q, and they are asking you what is the Cartesian product of P, comma Q. The number of elements they are asking, that is n of p cross q they are asking. So in P there are 3 elements and in Q there is only 1 element. So 3 into 1 is equal to 3. So the number of elements, number n of P cross Q is equal to 3. Option B. In next question, we are given A equal to 1, comma 2, B equal to 2, comma 3, and C equal to 3, comma 4. Which of the following statement demonstrate the property of Cartesian product? We saw many properties before. Let's see which is correct. For A, for A, we have to first find our LHS. So in LHS, B union C is what we have to find out first. It will be 2, comma 3, comma 4. And for A cross B union C, in A there are 2 elements and in B union C there are 3 elements. Thus, you'll be getting 6 elements and it is being given right. So, first is our correct one. Let's check the rest also. For B, B intersection C is the first what we have to do. It is 3. Then for A cross B intersection C, we will be getting just 2 elements, which is what they have given also. So, of course, this option is also right. What about the C? In A union B, we will be having 1, 2, and 3 as our element. And for A union B cross C, we must have 6 elements, but there are only 4 elements given. They skipped 2 elements. So this option is a wrong option. For D part, we are asking A cross B. For A cross B, we must have 4 elements and same B cross A also, we must have 4 elements. But they have given you just two elements for each, which is wrong. So only the first 2 options are right and the last 2 options are wrong. Moving on to our next question. They are giving you A cross B and they are asking you to identify what is A and what is B. So for A and B, all the first elements in A cross B becomes our elements of A. So P, M are the elements. For B, it is P, Q and R. So where is the option for that? It is A. So option A is correct. Next question. They have given you A as natural number less than 3, which is 1 and 2. B as the even prime number, which is 2 alone. So for A cross B, we will be getting 2 elements. One is 1, comma 2 and another 2, comma 2. So option A is right. So next, we are moving to relation. So what is relation? We already saw. It is a formula defined as a subset and of a Cartesian product of those two sets. So whenever you are given a two non-empty set A comma B and any subset R of Cartesian product A cross B, it is called relation from A to B. And we will be denoting it as R contained in equal to A cross B. Let's see what is domain, what is range, what is the connecting elements. So domain is the relation of R. What's happening here? Domain is the relation of R. Set of all first elements. So what all you called it as A. what all you had it as your first elements. All those elements are called your domain. It is always a subset of the initial set. And what is the range? So what all the elements you're going to have as the answer? The set of all second elements of the ordered pair, that is your B. So what will be the connecting elements? It is just the relation. It is the condition between those elements allowing us to filter and define. If they would have given you natural numbers alone, you will be defining natural numbers alone as your set. Likewise, what all the filtration we are getting, we will be filtering it and defining a subset. See, a visualizing of relation is being given over here. So they are given A as 1 to 3, B as 2, 4, 6. And they are asking as X is a factor of Y. So element of set A is being written here and set B is written here. So what will be the relation? 1 will be going to 2, 2 will be going to 4, and 3 will be going to 6. So thus we will be writing the relation as so. This is what we did so far also. See, you will be having 6 elements over here. Here are some practical examples of relation. Is greater than from set 5, 6, 7 to 1, 2, 3. Then our example will be 5, 1 and 6, 2. Likewise, there are some small examples. You can note it out. Okay, so what is definition of relation? A relation is is from set A and set B. A subset of Cartesian product A cross B establish some connection between them, and the such is called your relation. So it is just a link between them. You'll be having 1, 2, 3 over here, A, B over here. You'll be linking like this. So this will be defined over a function. You will be given a function, and such is called a relation. Over here, here is an example. A equal to 1, 2, B equal to 3, 4. Then what will be our relation? It will be 1, 2, 3 and 2, 4. This will be a valid relation of A to B. So coming back to domain, we already saw codomain and range. We are going to see for now. Of course, so first of all, with domain, it is all the set of all first elements, that is the input, in order to pair of relations. What will be our codomain? The entire set of B, not just a filtration. It will be the whole set. And the range is just the second element of the B. That is after we do our filtrations and all. So see, in example, the relation is 1, 3 and 2, 4. So what that means, our domain is 1, 2. Our codomain can be 3, 4, 5 or 3, 4, 5, 6 or some 1, 3, 4, anything. A codomain can be anything, but the range is the thing of elements which is in our B set, which we got after our filtration. So representing relations, there are 3 kinds: roster method, set builder method, and arrow diagram method, which probably you would be using, I think. So for roster method, it is just the ordered pairs, so long what all we saw. Over here, there is an example. R is equal to 1, 2, 3, 4, 5, 6. or some A comma B, B, C comma D, E comma F, like this. What all you're gonna write it in an ordered pair, that is called your roster method. Going on with your set builder method. Set builder method is your set which defines the function. Here they have defined a function x comma y where y is equal to x plus 1. So all your y will be your x plus 1. So here is what you can do. So your x can be 1, 2, 3, 4, etc. Your y can be 1, 2, 3, 4, 5, 6, etc. So this is your domain, this is your codomain. But what is your range? It will be just your x plus 1 after you do your x plus 1, after you do that filtration. So when you give 1, it will be going to your 2. So when you go for 2, 2 plus 1 is 3 over here. For 3, you'll be getting answer 4, and 4, you'll be getting 5. So though your domain is 1, 2, 3, 4, your codomain is 1, 2, 3, 4, 5, and 6. But your range is just 2, 3, 5, 4, and 5. So this is what you'll be writing it as an ordered pair. 1, comma 2, 2, comma 3, 3, comma 4, and 4, comma 5. Arrow diagram is nothing but the visualization of mapping, the one which I draw now also. This is what your arrow diagram means. Let's see arrow diagram examples. So I'm going to visualize a relation with the domain 1, 2, 3, codomain 4, 5, 6. So the arrows here 1, 2, 3, here 4, 5, and 6. And I'm going to add your arrows. 1 goes to 2, 2 goes to 5, and 3 goes to 6. So diagram clearly represents that the relation is 1, comma 4, 2, comma 5, and 3, comma 6. Here I have written an ordered pairs. See, in many ways you can match your 1, 2, 3, etc. or A, B, C, etc. Next, we are going to see a special relation, which is a null relation, or you can also say it as an empty. You'll be going with a symbol like this, a 0 and a dash. So for definition, a relation with no ordered pairs, there will be no ordered itself, no A comma P itself. So such is defined as a null relation, and it is denoted as R is equal to, we will be saying that notation as pi. See, for example, over here, A equal to 1, comma 2, B equal to 3, comma 4. Here R is empty. That means no element of A is related to element of B. They would have been asked that R, what all the functions which is A intersection B. See, there is no element which is common in A and B. Therefore, it will become an empty set. So this is one of the example you can say for this. So that's null is nothing but there is no connection existing between the two sets. Let's see some simple exercise in it. So here A, B, R, everything given, we have to find domain, codomain, and range. Domain is all the first elements, right? So here I'm going to collect all the first element of ordered pair 1, comma 3. From relation, I have to write. Then I have to go with the codomain, which is all the elements in B, so 4, 5, 6. Then for range, I have to write it from the relation after filtration. That will be 4, comma 6. Thus, two elements from A, 5 elements from B, Though it remains a part of those sets, those won't become a domain nor range. Let's see some more things. While sums in relations, we are going to see some more numerical properties. Here is an example scenario. A equal to 1, 2, 3, 4, 5. B equal to 4, 5, 6, 7, 8, 9, and 10. The relation here is A comma B belongs to R, where A plus B is equal to 9. So whenever we add it up, we have to get 9. Those will be our range. So for relation A comma B, A plus B equal to 9, we will be getting these pairs first. 1 comma 8, 2 comma 7, 3 comma 6, 4 comma 5, and 5 comma 4. So what all will be our domains? All the first element, 1, 2, 3, 4, 5. And what will be our range? All the second elements, 4, 5, 6, 7, and 8. And what will be our codomain if being asked? All our P set, which is 4, 5, 6, 7, 8, 9, and 10. Moving on with function. Already we saw the definition of function. It must be getting only one element of codomain. So in notation, we will be saying f from A to B. This in wordings, if I have to say, f from A to B. That is what the meaning of this notation. So here your key requirements is no element in domain can have a multiple element in codomain. In here, see example 1, comma 4, 2, comma 5, and 3, comma 6. Each is having only one element as the output. Let's see what is a valid function and what is not. In first, see that f of x is equal to 2 into x. So a is 1, comma 2, comma 3 and b is 2, comma 4, comma 6. When we apply our rule, that is 2 into x, for 1 we will be getting 2, for 2 you will be getting 4, and for 3 you will be getting 6. So each and everything maps to a different and exactly one output. So this is a valid function. But here 1 comma 2, 1 comma 3 and 2 comma 4. For 1, it relates to 2 and 3. It relates to 2 and not just 1. So it is violating a requirement and thus it is not a function. So with this, let's end up our session for today. And in next class, let's see the continuation. Thank you. Yes, sorry for the interruption. So modulus is an absolute value of a function. That is, we won't be getting any negative values for anything. So why it is a V, as I already told, for 1, 2, 3, you'll be having the graph going like this. And for -1, -2 also, you'll be getting the values 1, 2, 3, etc. Thus, the graph will be like this, thus forming a V-shaped. So only we will are saying it as a V-shaped function and thus it is called the absolute value function also. So see this example y is equal to x minus 2. The graph will be like this and this point will be your 2. So examples for each and every functions let us see. So for linear, we can have y is equal to 2x plus 1. For quadratic, you can have y is equal to x square minus 4x plus 3. For cubic, y is equal to x cube minus x. Or you can have for linear just x alone. For quadratic, like x square plus 3 also can be a example, or x square alone. For y, for cubic, it can be x cube minus x square plus x plus 7. Anything. That is, for linear, the power has to be 1. For quadratic, the power has to be 2. For cubic, the power has to be 3. So constant, we already saw, for any function, we have to get only one constant value. For reciprocal, it is just the reciprocal of the function. So if it is x square, then reciprocal of the function is 1 by x square. So modulus is what we just saw. So y is equal to modulus x minus 3. The function will be like this, and this value will be your 3. So let's have a recap, a key concept to remember. Relation versus function. So that is, every input must have exactly one output. That is called a function. In relation, that is not the case. For domain and range, domain defines all the possible input, and range defines all the possible outputs. That's the fundamental to understanding how a function behaves. So for a function composition, the composition is a combine of functions. It allows us to build a sophisticated mathematical model from a simpler function. And for graph recognition, we had straight lines, parabolas, S-curve, horizontal line, hyperbola, and last but not the least, the V-shapes. So for absolute value behavior, our V-shape is the example. So the modulus function which reflects even a negative input to a positive output. Thus, it maintains the non-negative results. So let's understand the relation and the function. For our recap, thus the relation is a set of ordered pair, that is 1 comma a, 1 comma p, and 2 comma c as example. You can see one is having two outputs, a and b. But this can't be done for a function. For each and every input, you must have exactly one output alone. So for that, we used the vertical line test. We saw how many times the lines is intersecting the graph. If it is one time, then it is a function. If it is more than one, then it is not a function. So that's with this recap, we finish this video. Let's see in our next video. Thank you.